So today we're going to put all of the factoring together, and we finish the unit with factoring completely. So if we take a look at the example at the top of the page, it says consider the trinomial 3x squared plus 15x plus 18. A, what is the GCF of each term in the trinomial? The greatest common factor of each term, 3x squared, 15x, and 18, well, they all don't have a variable, so there's no GCF as a variable, but 3, 15, and 18 are all divisible by 3. So the greatest common factor is 3. Write the trinomial as a product involving its GCF. So the product would be GCF times the quotient. Because for a product, that's factor times factor. So what do we multiply? We actually multiply the GCF times the quotient, what we would get if we multiplied this whole thing by 3. So that would be 3 times 3x squared divided by 3 is x squared, plus 15x over 3 is 5, and then 18 over 3 is 6. How does the trinomial inside of the parentheses now factor? So now this can be factored. So x squared plus 5x plus 6. That would factor, we'll set up your two parentheses because it's a trinomial. We have x times x, okay, to get the x squared. And then factors that multiply to 6 and add to 5 would be 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. Multiplying to a positive and adding to a positive means both sides or signs are plus. So write that expression in its completely factored form would be 3 times x plus 3 times x plus 2. All of these have to multiply back to that original trinomial expression. Okay? So factor completely means you factor till you can't factor anymore. Okay? So this means you may have to do more than one type of factoring. So the first thing you want to do is always, so this is laid out for us again, kind of guiding us through the process, is checking for that greatest common factor. Okay? If there's a greatest common factor, you want to factor it out first. So step 1, factor out a GCF if possible. If there's a -1 in front of the leading term in standard form, factor it out. Okay? So factor it out if there's a -1 in front. So right here in the example, -2x squared, you want to factor out that -1. So in doing so, that would change that to a positive 2x squared. And change all the signs to its opposite. Okay, divide 5x by -1, you get -5x. Divide the -2 by -1, you get positive 2. Then we factor out what's left. Okay, if it's the difference of two perfect squares, so that if it's in the form a squared minus b squared, remember that factors a plus b times a minus b. And then if it's a trinomial, okay, it factors into two binomials. Okay, with the trinomial being ax squared plus bx plus c. So now the steps are all written as notes. Let's actually take a look at some examples on the back. Looking at number 1, okay, first check for a GCF. Ax squared minus a. You can hear me say it. The GCF is a. So remember, it's always set up as the GCF out front, then one parenthesis, and that's your quotient. What do you get after you divide this by a? So ax squared divided by a would be x squared minus 1. And then you look at your parentheses. Can that be factored? Yes, that's dots. So that factors x plus 1 times x minus 1, bringing down the a that's factored completely. Number 2, 4x squared minus 4 minus 24. The GCF is a 4. Pull out the 4, we get what's left over after we divide, x squared minus x minus 6. Can that be factored? Are there factors of a -6 that combine to a -1? Yes, there are. So setting up, it's a trinomial, your two parentheses. Factors of 6 that combine to 1 are 3 and 2. So it'd be negative 3 plus 2 to get that negative 1. 3, 16a to the 4th minus b to the 4th. There's no GCF, and we have two terms. So is this dots? Okay, 16 is a perfect square, a to the 4th, b to the 4th are perfect squares because the exponents are even. So up front, to get the 16x a to the 4th, that'd be 4 times 4 to get 16, and a squared times a squared to get a to the 4th. Signs are different, so 1 plus 1 minus, and then to get the b to the 4th, that would be b squared times b squared. Now we look at these two, can we factor again? Well, we can't factor the first one, the sum of two squares, but we can factor this as dots again. So set up the two parentheses. It'd be 2a times 2a to get the 4a squared. Signs are different, and then b times b to get the b squared. So as a final answer, don't forget to bring all the factors down, would be those three binomials multiplied together. 2x to the 4th, 6x cubed, 80x squared. So they're all even, and the lowest number is a 2, which does go into each, so that's my GCF for numerically. And then algebraically, your GCF is going to be your lowest exponent, so 2x squared. Another way of dividing is to ask yourself, well, if I have 2x, what do you need to multiply it by to get 2x to the 4th? And that would be x squared. 2x squared times what is going to give you 6x cubed? It's negative, so it's got to be negative. 2 times 3 is 6, and x squared times x is x cubed. And then minus to get the negative 80. We already have the x squared, so 2 times 40. Then looking in the parentheses, do we have factors of 40 that combine to 3? And we do. 8 times 5 is 40, and 8 minus 5 is 3. So bringing down the 2x squared and factoring the trinomial, it's going to be x times x. Factors of 40 we just said are 8 and 5. Adding to a negative 3 would be negative 8 plus 5. And then the last one, or I'm sorry, one more before the last two, is x to the 4th plus 3x squared minus 28. There is no GCF, so I have to start factoring the trinomial like I would any other. Okay? The middle term here is going to give you a hint on what your leading term is. So if the middle term is an x squared, your leading terms are going to be x squared, and x squared times x squared does give you x to the 4th. Okay? For negative 28, so factors of 28 that combine to 3 are 7 and 4. You want a positive 3, so it's got to be a positive 7 minus 4. Okay? So that one was a little bit different. We didn't have a GCF, but now we're going to have to factor again. 7's not a perfect square, and also it's the sum, so we're going to bring that down. But x squared minus 4 is the difference of two perfect squares. So set up your two parentheses, x times x, signs are different, and 2 times 2 is 4. And now to finish. In 5 and 6, again, is when the first term is negative. We have to factor out a negative 1. So let's start by doing that first in number 6. Because there is no GCF, x squared, 9x, and 8, factor out the negative 1. It's going to change all of this to a positive. Okay? Are there factors of 8 that combine to 9? Yeah, 8 and 1. So bring down the negative 1, or just bring down the negative. You don't have to write the 1. So it'd be x times x. 8 times 1 is 8, and 8 plus 1 is 9. Signs are both positive as they multiply to a positive and add to a positive. And then 6, we can pull out that negative 1 again, but they have a GCF. So 3x squared minus 6x minus 3, we just pull out the negative with the GCF of 3. So instead of pulling out a positive 3, we pull out a negative 3. So negative 3 times x squared, think about it as distribution and not division, is negative 3x squared. Negative times a positive would give you that negative and be 2x. And then positive 1. Are there factors of 1 that combine to 2? Sure, 1 times 1. So x and x, 1 times 1, signs are positive, add to positive, plus, plus.